So good afternoon everyone. I'm Arpita Agarwal, Assistant Professor in CSC Department in AKGEC. So today I'm covering a topic of DSTL second year and subject code is BCS 303. So today I am taking a topic of reflexive symmetric and transitive. So it is an important one for AKTU, this topic. So suppose we have a set and relation. We have a set S having elements 1, 2, 3, 4, 5 and relation on set S is, suppose we are 1, 1, 1, 2, 3, 4, 2, 2, 3, 3, 4, 4, 5, 5. Then we have 2, 1. Then we have 2, 3. Then we have 3, 2. Then we have 2, 4. Then we have 4, 2. Then we have 2, 5. Then we have 5, 2. So then we have 3, 4. 4, 3. Then we have 4, 5 and 5, 4. So we have to find that it is reflexive, symmetric and transitive or not. So reflexive property says A, R, A. A relation is reflexive when it is having a relation on itself. So we are having this set. So it is reflexive when we have our set which is having a relation with itself. So suppose we have R. So we have 1. We check it for reflexive. Yes, 1, 1 is there. Relation 1, 1 is there. So set ka set se relation, that is 2, 2. Next we will find 2, 2. Is 2, 2 is present? Yes, 2, 2 is present. Next we will find 3, 3. Is 3, 3 present? Yes, 3, 3 is present. Now next element on the set is 4. So we will look, is 4, 4 present? Yes, 4, 4 is present in the relation. Next we will look for 5, 5. Yes, 5, 5 is present in the set. So we can say that set relation R, do write this, relation R on set A is a reflexive relation. Why it is reflexive? Because it is satisfying ARA, खुद का खुद से relation, that is 1, 1, 2, 2, 3, 3, 4, 4 and 5, 5 reflexive properties. Now we have to check whether the relation is symmetric or not. For checking the symmetric relation, we have to look the condition A, R, B. That means if 1, 1, 2 is there, then its reverse 2, 1 will be there, should be there. So for checking the symmetric relation, we look it for 1, 2. If 1, 2 is present, then we look for 2, 1. Is 2, 1 is present? Yes. So 1, 2 is there, then 2, 1 is also present. Now we look for, if we have 3, 4, then we will take the reverse of 3, 4, that is 4, 3. Is 4, 3 is present in the relation? Yes, it is present. Now we will take 2, 3. If 2, 3 is present, then 3, 2 must be present. Yes, 3, 2 is also present. Now, next we check 2, 4. If 2, 4 is present, then 4, 2 must be present. So, next we check 2, 5. If 2, 5 is there, then 5, 2 must be present. Now, we check 3, 4. 4, 3 is already there. We have written that. 4, 5. 5, 4 is also there. So, it is satisfying the condition ARA, that is A equal to B. That means reverse is also ARA. If ARA is there, then BRA must also there. So, this condition is satisfied, like 1, 2 is present, then 2, 1 is present, 4, 3 is present, then 3, 4 is present. Like 2, 3 is present, then 3, 2 is present, 2, 4 is present, then 4, 2 is present. So, all the terms are present. So, we can say that relation R on set A is symmetric relation. Now, we check for transitive relation. So, transitive relation says if ARB is there and BRC is there, then ARC should be present. So, we have checked if 1, 2 is present, check for it. We have 1, 2 present and we have 2, 1 present. Okay. So, 1, 2 and 2, 1. So, is 1, 1 present? If we cancel 2, 2, then 1, 1 is present? Yes. Now, if we look for 3, 4 and 4, 3, then if we cancel 4, 4, then 3, 3 is also present. Now, if we took next, suppose I took 2, 1. 1, 2 is also there. Yes, 1, 2 is also there. So, 2, 2. Yes, 2, 2 is also present. Now, if we check 2, 3. 3, 2 is also there. That means 2, 2 is also there. So, we can say that for every element, if ARB is existing and BRC is existing, then the ARC is also existing. So, we can say that relation R on set A is a reflexive relation. So, next we will study about equivalence relation. So, what a equivalence relation is? A relation that satisfy the reflexive, symmetric, and transitive property then the relation is reflexive relation. So when we come to previous slide, so this relation, can we say this relation is equivalence? Yes, this is an equivalence relation because this relation is reflexive also, this relation is symmetric also, and this relation is transitive also. Can you check it? Reflexive, satisfying the reflexive property, satisfying the symmetric property, satisfying the transitive property. So we can say hence the relation R on set A is an equivalence relation. So now we will learn how to calculate the composite relations. Suppose we have a question, we have two relations R and so we have to find some composite relations on it. Like we have to calculate ROS, ROR. So how we will calculate ROS, and suppose we have to find SOR also. So how we will be calculating it? First we will find ROS. So these two relations are given. So how ROS will be calculating? ROS. So we have S this and R this. So ROS says means 4, 2. We will look where 4, 2 is coming, where 2, this is ending in 2. So we will look in R where 2 is ending. In this 2 is, it is starting with 2, it is ending with 2, and it is starting with 2. So we will make a transitive relation for it, 4, 2. So we have combined two relations and used transitive property for it. Like we were having 4, 2 and in S 2, 2. So we will cancel S 2, 2. The remaining answer will be 4, 2. Now next we will look 2, 5. Is there anything started from 5? No. Any relation is not starting with 5. So we will leave this. Now we have 3, 1. Is any relation starting with 1 in R? Yes. Cancel 1, 1. Relation will be 3, 2. Now we will be, next relation is 1, 3. Is any relation starting with 3 in R? Yes. 3, 4. So we have 1, 3 and 3, 4. So 1, 4. So ROS means we will be taking the S term first, making it as compound statement with second relation, that is R, and we will be calculating it in this way. Now we will calculate SOR. So SOR will be, what will be our SOR? ROS we have calculated. Now SOR will be 1, 5, 3, 2 and 2, 5. So how it is come? Again we will be taking R as first term, because last term will take as first term and S will be as second term. So 1, 2. Any relation starting with 2 in S? Yes. So we have 1, 2 and 2, 5. So cancel 2, 1, 5. So again 3, we will be taking R 3, 4. Any relation starting with 4? Yes. 3, 4, 4, 2. Cancel it, 3, 2. Next we will be taking R again 2, 2. Any relation in S starting with 2? Yes, 2, 5. Cancel 2, 2. Answer will be 2, 5. In this way we have calculated SOR. Next is our ROR. ROR means R square. So how R square will be calculated? First will be R, second will be R. So ROR 1, 2. Any relation again, if we take R 2 times, 1, 2. Any relation in second R starting with, write it again, R 1, 2, 3, 4, 2, 2. Again R 1, 2, 3, 4, 2, 2. So ROR, that means R square. If we take R, this R 1, 2, any relation starting with 2? Yes. So answer will be 1, 2 and 2, 2. Cancel 2. Answer will be 1, 2. So if we take 3, 4, any relation starting with 4? No. Now we take 2, 2, any relation starting with 2? Yes. So this is our ROR. Now you are clear with how we calculated compound relations like ROS, ROR and SOR. So that's all for today. Thank you.